let's try to make this example a bit more concrete by going into
Hmm.
a specific use case. So, you and I were planning on later in the episode talking about global supply chain networks and how the pandemic kind of broke these, and how reactive data processing combined with IoT, Internet of Things hardware
Hmm.
could help make rather global supply chains more resilient to abrupt delays and shocks. So maybe let's dig into that specific use case now, so that as we kind of address other questions around how reactive data processing works, we can like tie into the specific concrete example.
Yeah, so actually, we started Pathway working closely with actors in the logistics industry, working to improve global supply chains and global transportation patterns. Logistics is a pretty fascinating area because if you look at the importance, the value, and the scale of the industry, it's about something like 10% of the world economy.
Oh
So it's
wow.
really big. It's highly concentrated, and a lot of the value is in international trade, uh, trade that goes on containers, trucks, large vehicles, and it's in some sense, from a data processing perspective, when we were starting, this was largely terra incognita. It was a rather new world of analyzing this type of data patterns related to logistics assets. What IoT gives in this setting is the ability to trace moving assets, be it containers, trucks, parcels, you name it, end to end. That is, you attach a sensor and you have the whole trace, the whole tag of an asset that's moving. This leads to an interesting situation in which something like 10% of the world industry has some of its most important data lying in one data schema, one data format, which is essentially a big table of events related to moving assets. It's a table whose columns are something like timestamp, asset ID, location, XY, GPS, latitude, longitude, and the type of event that happened, whether it was a kind of just a measurement of a location, whether there was a measurement performed by IoT, for example, of temperature, pressure, door opening, some kind of alert. And this kind of table actually captures a lot of other things in logistics as well. For example, if there's a facility where your parcels are being scanned, all such scan events also enter in this type of table. So you have one kind of input data table, data schema, which seems to capture everything that's happening, but which is quite unusable from the point of view of business intelligence, analytics, and process monitoring and observability used directly, just because it's super hard to query. It's hard to express in a language such as SQL a query on the data, which would extract what's important. And the important questions are related to process, things that are happening. So, for example, a logistics client may be interested in knowing what are the risks of anomalies of a given type, like shocks, happening to your sensitive pharmaceutical shipments in the next 2 days on a given route, let's say Rotterdam to New York. And if you look at the data inputs, all the information is there. We've given a lot of man years and a lot of patience. You could probably get it in the end by hand, but it's not all that easy to extract and automate over global processes. So that's where we started. We started working with a process of enriching this data automatically, converting the schema to add structure to it in such a way that it's actually possible in real time to get an enriched data schema which is queryable and which reveals information about the process. A lot of aspects to it related to, first of all, trajectory mining, understanding how things flow, uncovering automatically the key locations. So this is like automatic geofence detection in the lingo of the sector. It's about understanding anomalies, congestion, delays as they happen, or even before they happen, and putting into place predictive models. So there are many steps here, and already getting all of this done in a batch setting, a setting where you have all the data available, like just historical data, is a challenge to express it cleanly and to get an analysis of a snapshot, so to speak, of the data, and it gets extremely complicated if you, on top of this, you would want to manually create logic in a way which would take into account changing data. It becomes a task which is both tedious, error prone, requires a lot of duplication of logic between the, let's say, the offline case and the online case, and so on. So our effort was, on the one hand, to automate this, and on the other hand, also to figure out what models in machine learning, what transformations of data are actually amenable to this type of approach. Basically, say, forget what cannot be done, focus on what can be done here and now, and make it possible to make this robust. So just to give you an example of the types of data processing routines that we have, we've designed to work robustly across different modes of transport, be it ship, truck, train, uh, container, or vehicle, even working for small assets like parcels, sometimes with animals, sometimes with public transportation. So basically, to have models which work with very little or minimal awareness of what is actually being traced, what type of asset is being traced, to allow changes to this process, to allow new modes of transport to be introduced, to allow changes to the logical process. If you follow like what your couriers and delivery people are up to before Christmas, it's actually amazing how the whole logistics network adapts. There are new depots being opened, temporary depots. There's changes to the process. Things are happening completely differently in peak season. And if you want to make sense of it, you have to have a system which is able to take into account these changes as they happen. New depots open. Okay, it's not something that you will want to manually introduce. It's something that you have to kind of capture from the data.
Wow. Okay. Yeah. So that is very concrete and crystal clear. So these real time data products, reactive data processing frameworks like Pathway allow data models to be applied to complex systems like a delivery system, like the global supply chain network. And it's reactive automatically to things like vastly greater volumes in peak season around Christmas time, heading into Christmas time, including things like hubs coming online that previously weren't there. And so you don't want to be going to your data scientists and saying, "Hey, a new hub opened up um, yesterday. It's December 1st, and a new hub opened up. We need you to retrain all of the machine learning models that we had to be able to account for this new hub." And then the very next day, two more hubs open up because we're one more day closer to Christmas. And you're like, "Sorry, data scientists, we got two more hubs. We need to retrain that data model again." And every time the data scientists are like, "Oh, this is going to take like a week." And so instead, with a reactive data processing system, it's flexible to these kinds of changes automatically.
Yeah, and that's exactly the spirit. It's kind of also changes the whole workflow, the way the non-technical user can interact with the application. So you can have an expert in the domain who is working with a system, and rather than asking data scientists to update models, they either get, in the case of a simple model, you can actually redeploy the model as it happens, or in some case you get a question whether you want to update your model or you update your data. So if we talk of these hubs that open at the beginning of the day, whoever's managing the dashboarding part of the solution gets information that we have detected 20 new hubs which opened since yesterday. Please approve or correct errors. And essentially, the work of this person is more in fine tuning or fixing things that were not detected with, let's say, 100% accuracy, or performing small corrections to the automatic labeling that's being done, rather than actually introducing or driving the change process manually. Just to say, from our perspective, this is where we started out with. So we started with one concrete data product in logistics, and this is our flagship data product. It's being used by major companies, freight forwarders like DB Schenker, which is third worldwide largest freight forwarder in the world, by the French postal services, which also have a wide international network on this, operating in other countries as well. So the kind of use there is what we see and we feel. At the same time, what we are delivering is this ability of data scientists and data engineers to work in the same way as we do. So we want this. We want to share the experience. We want to share the experience both with everybody, with the wide community, and also with the data teams of our clients, to work closely with them, to allow them to modify the data pipelines, to include new data sources. So it's really very much about giving this full development experience, and having it work with like having it work as a developer tool.
Nice.